Welcome again. We're on lesson 5.3 right now, but I ran out of time on the 5.2 lesson to re-explain how to turn in your answers. So I'm going to have you go to Schoology, and I just want to show you where you turn in your Schoology, or you turn in your answers. So go to Courses. Then you're going to go down to whichever class you have with me. I'll just pick this one as a random one. Then you're going to go to, well, this is the same for last week, but you're going to go to whichever lesson you're on. So we're on 5.3. And once you're done with this video lesson, once you're done with the red boxed questions, you go to this little puzzle piece that says 5.3. Go ahead and click on it. It'll open up with a Schoology quiz. Now, it's not actually a quiz. It's just a place for you to put in your answers. Again, I'm a teacher, so I can't see what it looks like right now. So the puzzle piece that says 5.3, you're going to take all the answers that you get that are from 1, 2, 3, and then 4 and 5, and then put them in there. As soon as you put in your answers, you can try 20 times. So basically unlimited times to get it right. It is scored on right and wrong, but make sure you review your answers because that'll help you get the right answer. Okay, today we have a subject that is going to take your brain and make it 10 times bigger because we're talking big ideas here. It's not just about solving equations, it's about holy moly, what's going on with these weird answers I'm getting and what do they mean? I'm really excited about this. Let's take a look here. This is a balance, and so it's the same idea as a hanger. And we want to know, does this have, is it always true that these two sides are equal? Is it sometimes true or is it never true? So let's take a look. We know that x's have to be the same, right? They could be any number. We don't know what they are yet, but they have to be the same. So if we were to say, okay, on one side of the balance, I can do the same thing to both sides of the balance and it'll stay equal. I'm going to take away 3 x's from both sides. All right, so now my equation or my balance says that I have 4 equal to 10. Is that true? No, that is not true. 4 is never the same as 10. And so we would say this one is never true. Let's take a look at what would this look like if we turned it into an equation and did the same thing. Well, I see that I have a group of 3 x's on both sides. So if I were trying to solve this, I would try to cancel the x's that are on the right. That's always my first step. Maybe you do it a little differently, but you'll get the same idea. And when I cancel the x's on the right, I get 0 over here, but then I'm also getting 0 over here. And so what happens when I try to cancel on one side is I end up canceling on both sides. And then I get an equation that is not true. 4 is not equal to 10. So we would say this is never true. And another way to say that in math terms is that there are no solutions. So we're going to use the phrase no solutions, or it can't be solved, as our answer here. Okay, let's take a look at the next balance. The next balance says, okay, I have 3 x's and 3 x's and a group of 4 ones and a group of 4 ones. It's the same. So no matter what I put in for x, right, if I said, okay, x is 2, well, then every single x has to be 2, and then I would have 10 on both sides, so that's true. What if I did 3 for x, right? Again, same idea. We get 9 plus 4 is 13, get 13 on both sides no matter what. So this one would be always true. Let's take a look at what it looks like when we see it in equation. It says 3x plus 4 ones, and then we have 4 plus 3 x's. It's the same thing on both sides. So let's say we just tried to start solving it and didn't realize this. I would want to cancel my x's on the right. So I have minus 3x. So the same thing is ending up happening. I cancel on both sides. But then I see that I have 4 is equal to 4. Well, that's always true. All right, so here's the big idea, is that sometimes if you have the same thing, the exact same thing on both sides of your equal sign, it is always true. Always true. Which means that x could be equal to anything. It could be a billion zillion different things and it would still be true, right? We could plug in anything for x and it would be true. Another way to say that is infinite solutions. Okay, last one here. Let's take a look. I see that I have, okay, this group of 4 ones and this group of 4 ones. Well, I could take both of those off, right? I could take both of those off. So could 2 x's ever be equal to 3 x's? Doesn't seem right, but let's take a look at the equation and see what happens. So here I have an equal sign in the middle. I have a group of 4 ones and then 3 x's over here. I have a group of 2 x's and 4 ones over here. So I'm going to cancel the x's on the right, on the right. I get negative 1x is plus 4 is equal to 4. Then I cancel the numbers on the left, on the left. So I get negative 1 is equal to 0. Remember, add top to bottom. Okay, so this is really strange. If I were trying to solve this and I got here and I realized that that was going on, I would be very confused. But let's continue our song. Last divide by the number that's in front of the x. So if we divide 0 divided by anything on a calculator, let's get this out. 0 divided by anything, but in our case, we're dividing by negative 1, is always 0. So the only way that this could be true is if we had x equal to 0. So we could say it is sometimes true. Sometimes true. And another way to say that in math terms is that x has to be equal to 0 to make it true. Okay, let's do a few examples. I'm going to go pretty quick through them, and I just want you to kind of think about if you could just look at it quickly and figure out what the type of solution you're going to get is, and then also what would happen if you didn't really look at it that carefully and you tried to solve it. So I'm looking at this, and I notice that, okay, if I were highlighting, the groups of ones are the same. So the groups of ones are the same on either side of the equal sign. What does that mean? Try to figure it out. So first you cancel the x's. First you cancel the x's on the right, on the right. So we get negative 4x plus 12 is equal to 12. Then you cancel the numbers on the left, on the left. So I'm minusing 12. Always add top to bottom. And what ends up happening is we get that they cancel on both sides, so we have 0. Okay, so what does that mean? Let's divide by the number that's in front of the x. And we get x is equal to 0 when we divide top to bottom. So whenever you have the same group of numbers on both sides, but different groups of x's on both sides, then you know that x must be equal to 0. Let's look at the next one. All right, what do we notice about this question? Well, you'll notice that both groups of x's are the same, but the groups of ones are different. What does that mean? Well, we're going to start solving like we just didn't realize it. See what happens. So first you cancel your x's on the right, on the right. So let's do that. Uh-oh, what ends up happening is we cancel both x's on both sides, even though we didn't try to. So we have a negative 9 is equal to negative 15. Is the number negative 9 the same as the number negative 15? No. And all of our x's just poof, disappeared, right? We canceled out both x's. So when this happens, we know we have no solutions, or never true is another way to say that. Okay, last one. So before we get started, let's say we were looking very carefully at it before we started solving, and you notice that the exact same thing is on both sides of the equal sign. So what does that mean? Let's see. Let's act like we didn't even notice. So first you cancel the x's on the right, on the right. So it kind of looks like the same things happening as last time. Poof, our x's disappeared. How am I supposed to solve an equation that doesn't even have an x in it anymore? Well, lucky for you, you can see that 1 equals 1. That's a true statement, right? No matter what, 1 is always equal to 1. So we can say this is infinite solutions, because no matter what we put in for x, we have something that is always true. Okay, now you're going to pause the video and you're going to try 1, 2, 3, and then come back. All right. I just have a couple more questions. Now we need to simplify these first. So we're putting up the difficulty level a little bit. Remember, when we see parentheses in our equation, we stop and we need to distribute before we can solve. Remember, you highlight and that will help you figure out where to distribute. So we didn't do anything with the 4x. We know that 2 times 1 is 2, so this is plus 2x. This is a negative 11. Remember, we're always multiplying by the number and the symbol to the left of it. Since this was a positive 2, it didn't affect the previous answer. And then again, this side of the equal sign is sleeping. Don't worry about it yet. All right, if it helps you at this point, we're going to highlight our different groups in our special colors so that we don't get confused and we don't forget which symbol is which. If we have two groups that are the same color on the same side of the equal sign, then we combine them together, which means add them together. And here we go. We have the same thing on either side of the equal sign. So which equation does that look like from our previous example? It looks like this one, right? Where we end up with the same thing on both sides of the equal sign. So we have infinite solutions. So on this one, we would say it is infinite solutions. And another way to say that is always true. Okay, last example from me, and then you're on your own. You can do it. Anything that's in parentheses, remember you are highlighting that to remind yourself you need to do that first. Then we're going to multiply through and rewrite. So something that might be a little bit helpful is if you have a number that is negative, it might be helpful to highlight the negative with that number just so that you do not forget that you need to multiply by the negative version of that number, not just the 11. It's negative 11, people, get with it. We're not going to do anything to this side of the equal sign. This negative 4 hanging out, not part of the problem right now. Negative 11 times 1 is negative 11, and then that's also multiplied by x. We're going to keep going. Negative 11 times negative 3. Remember, this negative goes with that 3. So that's going to be positive 33. Now we can highlight using that strategy. Remember, X is in green is how I've been doing it, but if you want to do it a different way, you're more than welcome to use different colors. Just try to remain consistent so that your brain is remembering which color is which. Now I notice I have two groups that are the same color, like terms, on the same side. So before I do anything else, I'm going to rewrite this. I'm going to add them together. So in my calculator, I would do negative 4 plus 33, and I would get 29 minus 11x. Now, you might notice that we have two groups of positive 29 on both sides. So which of our examples looked like that from before? We had this first one had the same group of ones but different group of x's. And so what's going to happen? We're going to end up getting x equals 0 as our final answer. So x equals 0 is going to be our answer. All right, finish these last two questions. Put your answers in the Schoology quiz for 5.3.